Welcome to the Chapter 6 test review. This covers exponent laws and multiplying polynomials. So we're going to start real quick with those exponent laws. The first of those is what's called the product rule. And what that simply says is that if I'm multiplying two terms with the same base, so x being the base in this particular case, and they each have an exponent, I'm going to simply add those exponents. The reason that that works, I will show you the example, is if I have x to the second times x to the third. X to the second is expanded to be x times x. Drop down that times. X to the third is x times x times x. So that goes to there. So if I expand that out, I'm multiplying x by itself a total of 5 times. So that is x to the fifth. So simply saying if you are multiplying the two, and that also counts when there's nothing there. Like if I have x to the fourth, x to the fifth, if I have no symbol there in between the two, or if I have parentheses around them, that indicates that I am multiplying them. So that would be x to the ninth. So that is the product rule. The next rule is the product to power rules, and that's saying that if I have a set of products inside parentheses, and that's being put to a power, to an exponent, then that applies to both things. So for example, if I have 2x all to the third power, keep in mind that that third power tells me I am multiplying everything in that parentheses by itself 3 times. So what this really is 2x times 2x times 2x. So if I rewrite this, all those things are simply being multiplied. So I could rewrite this as 2 times 2 times 2 times x times x times x. So 2 times 2 and times 2 is 8. X times x times x is x to the third. So that is the product to power rule. Something that you should know, however, I'm showing you why these work, but what I would expect you to show on something like this, say I had 4 parentheses, 4x to the second, then that would be 4 to the second, which is 16, x to the second, which is just x to the second, or x squared. So I'm showing you why these work for the first example, but you want to use the rule for it to save yourself some time. Similar to the product to power rule is the quotient to power rule, which simply says if I have a fraction dividing, which means it's called a quotient, to a power, then it applies to both the top and the bottom. So if I have, for example, 1/3 to the second power, that is equal to 1 to the second over 3 to the second, which is equal to 1 over 9. And the reason for that is if I go the long way, 1/3 times 1/3, that would be 1/3 to the second power. Whenever I multiply fractions, I go straight across. 1 times 1 is 1, 3 times 3 is 9. So same idea as the product to power rule. Next we have the power rule, which says if I have an exponent to the power of another exponent, I need to multiply those exponents. So if I have x to the third to the fourth, what that would be expanded out, and again this is the part you don't need to show, but I'm going to show you why this rule works. This would indicate that I have x to the third times itself 4 times. So I've got x to the third times x to the third times x to the third times x to the third. Now, I could expand these out further if I really wanted to. I don't want to, though. I'm going to use my product rule, which tells me if I'm multiplying with the same base, I simply add the exponent. So 3 plus 3 plus 3 plus 3, which is x to the 12th. The other way to go about that in the simpler way that I would do is just x to the 3 times 4, which is x to the 12th. The quotient rule, which is when we're dividing same bases to different powers, means we take x to the a minus b. And once again, I'm going to show you why that works. If I have x to the 5th over x to the 2nd, expanded out is x times x times x times x times x for x to the 5th. X to the 2nd is x times x. Now, part of this that you need to be aware of is that if I divide, if I'm only multiplying and dividing, that's when I can start crossing stuff out. If I divide x by x, or anything divided by itself, that gives me 1. And then 1 times anything else doesn't change it. So, like 1 times 20 is still 20. 1 times 50 is still 50, so on and so forth. So when I multiply by 1, that doesn't change anything. So when this becomes 1, I essentially cancel it out. I just don't like to use the word cancel out. I usually will use the term divide out. So these two sets divide out, and I'm left with 1, 2, 3, x to the 3rd. So the other way to go about this is just 5 minus 2 gives me x to the 3rd. So on that same note, if I have a coefficient with those, let's say I have 15x to the 4th over 5x just to the 1st. Remember, if it's by itself, it's to the 1. Then I need to look at this in two sets. 15 over 5 times x to the 4th over x. So this becomes 3. X to the 4th over x to the 1st is x to the 3rd, because I am subtracting 4 minus 3 to get 3rd. So that would be my final answer right there. That is the quotient rule. Next up, that kind of brings us to the negative exponent rule, and that is x to the negative a is equal to 1 over x to the a. Similarly, if I have 1 over x to the negative a, that equals x to the a. So it's important to note that whenever I have a negative exponent, I need to move it to make it a positive. And simplifying indicates that you need to get rid of all negative exponents. That's the implication there. So with the negative exponents, the reason this one works, let's say I have x to the 2nd over x to the 5th. According to my quotient rule, that would be x to the 2 minus 5. So if I subtract 2 minus 5, that gives me x to the negative 3rd. So the reason this one works, if I have x to the 2nd, so that's 2 x's on top, x to the 5th on the bottom, and I divide these out, what I'm left with are 3 x's, but they are on the bottom. So what I need to do, because these divided out to be 1, is this is 1 over x to the 3rd. So that is why the negative exponent rule works. All right, moving on. All right, so anything, zero exponent rule, anything to the 0 power is 1. Where you have to be careful is where the parentheses are and what exactly is being raised to the 0 power. Here's the reason this one works. If I have x to the 2nd over x to the 2nd, if I use my quotient rule, that is x to the 2 minus 2, which is x to the 0. Now, if I look at this in terms of what else I know, considering that anything divided by itself is always 1, then that just gives me 1. Another way to look at it is if I want to, I could expand it out. X times x over x times x. Those divide out. Remember, they don't cancel, they don't disappear, they make 1. So what I'm left with is 1. So anything to the 0 power is 1. And on the practice test, I'll show you some ins and outs of that. I think that's it for the intro, your exponent rules, and we will get to the practice test, I think actually I'm going to do that in a separate video. So make sure you see the chapter 6. Don't know when I paused that. Make sure you, after you watch this, you watch the step-by-step practice test for chapter 6.